Hello. Okay, so there's been some questions about problem 2.15 in the Frederick enclosed book. We'll kind of go over some of that. I gave you 2.15 as a practice problem. It's got the answers in it, so let's just go over it in detail here so that you get a chance to do it. First things first, let me just 2.15. Let me draw a picture of it. So in 2.15 we have two masses. So we've got a mass connected by the spring. Here is M2. This is K. Sorry, I have to look and see if this is K2. Sorry, don't know my numbers here. And then we had a spring and a damper that are attached to mass number 1. And this is going to be B, and this is K1. So we've got two springs and two masses. Now, even in the problem, they established datums. This is X2. We're going to establish this is the datum. This is X1. So here's our first free body. So now we have to do, what's the next step? Let's do a free body diagram, right? That's what we want to try and do. So let's do a free body diagram of mass 1. So free body diagram of mass 1. So here's mass 1. Let's just go ahead and repeat the datum. This is X1. Here's M1. And just so we don't forget, right here and now, let's just go ahead and put in our D'Alembert force, M1 X double dot 1. And now, if I move M1 in its positive direction, what I feel is I get a force from the spring that is K1 times X1, but that gets smaller. So if I move M1 in a positive direction, I get a big force. But if I move M2 in a positive direction, that force gets smaller. So I can write that this way. And equally, I can write this is going to be B times X dot 1 minus X dot 2. Make that a dot. And so those are my forces. So now I can write the equation of motion for the system here. The equation of motion is going to be, so here, I'll just write here. M1 X double dot 1 plus B1 X dot 1 plus, oops, I already messed up. Oh no, it's hard to erase this stuff. X dot 1 minus X dot 2 plus K1 times X1 minus X2 equals mg. So that's my equation of motion. I can worry about that. I'm going to try some different colors here. I don't think any of the colors work very well, so we don't know. So let's go ahead and do a free body diagram of mass 2. Also, let's do a free body diagram of mass 2. So it is possible at this point that I can just use Newton's third law to just go ahead and transfer these forces from mass 1 directly to mass 2. I'm going to go ahead and establish my datum. Positive, oh, it's hard to erase this stuff, X2, positive X2 goes in that direction there, so we'll do that. Okay, so I could transfer it, so even before I forget though, let me just do this because otherwise I'll just forget it. M2 X double dot 2. So we'll just establish our D'Alembert force. There's one more thing on this one. I didn't put it here. Oops. And that is the force F. So I'm just going to go ahead and put the force F on here. Force F, it goes in a positive direction. So rather than do that, what I'm going to do is I'm going to use the method in the book. So clearly if I move M2 in a positive direction, the only effective K2 is right here. So this is just going to be K2 times X2. So that's going to be that way. But, you know, so now if I move M2 in a positive direction, the effective K1 here, so M2, the effective K1 is going to be, I'm going to have a force here that's going to be K1 times X1. That's if I move M2 in a positive direction and I hold M1 constant. So M2 positive direction. Now I'm going to hold M2 constant and move M1 in a positive direction. So when I move M1 in a positive direction, I get this. So I got my subscript messed up here. That's X2. And this is K1 X1. I can put those in. Similarly, I don't have to do too much. This is also like a b times x dot 2, and there's another one that comes down like this that is b times x dot 1. And so what I can do, I can just add these things together. I can just add these together. So how should I add them together? Why don't I add them together so that x2 is the positive direction? So that means this is going to be k1 times x1 minus x2. And that is in a direction down. And this one here is b times x dot 1 plus x dot 2. Again, that is in a positive direction downward. So now I'm ready to add all of these forces together. I've got all the forces that I need, and I'm going to add them together. This is going to be m2 x double dot 2 plus b times x dot 1. Curse you minus signs. Minus x dot 2. And there's a minus sign here because look at the direction of the arrows there. So I've got to get all my minus signs right. But minus signs, that's your responsibility. Minus k times k1 times x1 minus x2 plus k2 times x2 is equal to mg plus f. That's m2g plus f. That's m1g plus f. So let's just get all the pieces together. So, you know, I can go through and organize this stuff in a good way. One of the things that I can do is I can look at static equilibrium. Static equilibrium. That means that all the terms with dots on them are negative. I mean, are zero. And so now what I'm going to do is I'm just going to write the equation. I'm going to write this equation. The static equilibrium is just going to be k1 x1 minus x2 is equal to m1g. So that's equation number 1. And now I'm just going to write the static equilibrium equation here. You know what I'm going to do is I'm going to break this into f0 plus delta f. And I'm just going to say for static equilibrium, delta f is equal to 0. So what I'm going to do is I'm going to write this again. K1 times x1 minus x2. Oh, there's a minus sign in front of there. Plus K2 x2 is equal to m2g plus f0. So this is equation number 2. So I've got 2 equations and 2 unknowns. I'm going to leave that to you to solve. I might then add a little bit of a break right here to talk to you a little bit about how to solve it using MATLAB. So let me just stop for a second. MATLAB, we don't need no stinking MATLAB. It's just 2 equations and 2 unknowns, so let's just do that, right? Okay, so I'm just going to write it down here. K1 times x10 minus x20 equals mg. I'll solve this for x10, right? K1 x10 is equal to mg plus K1 x20. That tells me that x10 is equal to m1, that's in 1, all those are 1's, g, plus K1 x20 all over K1. So now I'm just going to substitute in, here's the other equation, is going to be K1 plus K2 times x20 is equal to K1 x10 plus m2g plus f0. So those are the ones that I wanted to do. So let's just see here. I'm gonna substitute in for x10 here. This is going to be K1 times m1g plus x20, K1g over K1, m1g over K1, plus x20, plus m2g times f0 plus f0. So that's what x20 is equal to. Okay, so this is K1 plus K2 minus K1 2g plus f0. So that says that x20 is equal to m1 plus m2 g plus f0 divided by k2. Okay, so now we can substitute in here. This is going to be m1g over k1 plus x20, but we know what x20 is, m1 plus m2g plus f0 over k2. There's a lot of different ways of solving this, right? So I could do it this way, m1g k2 plus m1 plus m2 g times k1 plus k1 k2 f0. Oops, I'm falling off. Let me get this dot this. So sorry, I'm getting off of the dot plus k1 k2 f0 total over k1 k2. That's one way of doing it. Oh, there's other ways of simplifying it, but the reason that I put numbers in to problem 2.16 that I've assigned for you is so that I don't have to worry about this. I just can look at your number and see if it's right. Okay, so this gives me closed form solution for x10 and x20. Okay, we can use MATLAB. And so here I'm going to use the solve command in MATLAB. And what I can see here is that in the solve command, I can use the first equation and the second equation. And those equations are just symbolic. I need to tell it what the variables are, that is at the end of the equation. And I tell it to give me those variables. Now, the variables are never pretty in MATLAB, so maybe I need to simplify those variables a little bit. So I'm going to use this simple command. And that simplifies it some. And then maybe I'd like to have it look a little prettier than it is, so maybe I'm just going to let it be pretty, and then I'll get it both simple and pretty. Okay, so we're back. So now you know how to solve this with that using MATLAB, but this gives me x10 and x20. So in order to be, I should make, these are all the equilibrium positions, so I should put a little 0 subscript by it. These x10 and x20 are the equilibrium positions of that, and so that's all going to be good. And so now what I'm going to do is I'm also going to define a new 0 point. And the new 0 point that I'm going to define is going to say x1, so here we go. x1 is equal to x10 plus z1. x2 equals x20 plus z2. So I can, both of these things give me that x dot 1 equals z dot 1, x double dot 1 equals z double dot 1. I'm sorry, I put 2 there. I meant 1. It's so hard to erase. I'm no slob. Let me get rid of that. Good, perfect. X double dot 1 equals z double dot 1. X dot 2 equals a z dot 2. X double dot 2 equals z double dot 2. So now we've got some relationships. So let me just go ahead and plug in. Let me go ahead and plug in for equation 1. So here I've got equation 1. And I'm going to plug in this set of variables, what x1 is equal to. And so here's what I'm going to do. This is going to be m1 z double dot 1, right? Because I can just substitute in x double dot and z double dot, plus b times z dot 1 minus z dot 2, plus, I'm going to dot, dot, dot. In MATLAB we do that. Plus, this is going to be k1. So what is x1 again? x10 plus z1 minus x20 minus z2 is equal to m1g. And the whole point of this is, if you go back and look at just what the static equilibrium equation tells me, is that this, and this, they all cancel. Thus, I can just write this whole equation, m1z double dot 1 plus b z dot 1 minus z dot 2 plus k1 z1 minus z2 equals 0. Look, no mg. We've erased the mg term. So maybe what I might want to do, I might even want to do one more little thing here. Oh, I can't get very many good colors, but I might want to do one more thing here, which would be like this. I might want to do it this way. m1 z double dot 1 plus b1 z dot 1 plus k1 z1 is equal to b z dot 1, a 2, I'm sorry, that's a 2, plus k z2. I hope that didn't fall off the edge, but if it did, oh well. So now I'm going to go back and I'm going to start looking at, I'm going to look at this second equation. Let me just write that one again. This will have, I have a little bit more space here. m2z double dot 2 plus b2 times, or there's no 2 here, so I don't need that 2. Get rid of it. Okay, b times, this is going to be z dot 2 minus z dot 1 plus k1 z, oops, let me just get this right, sorry, let me just get it right. K1 times, this is going to be x20 plus z2 minus x10 minus z1, end parentheses. I've still got this plus k2, so k2 x20 plus z2 is equal to m2g plus f0. So if I go back and look again, what I'm going to do is I'm going to look at my static equilibrium equation, and I can see that this all cancel with these terms here. So I can just rewrite this entire equation. m2z double dot 2 plus b2 z dot 2 plus k1 plus k2 z2 is equal to b z dot 1 plus, if I got all my z2, 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 k1 z1 plus f delta f. There we go. So there's all our equations that we've got here.